log properties that we're going to be doing for everything that's here. All right, there's three we're going to look at. First one is a product property. And again, for this one, we're going to expand. And expand is what it sounds like. We're going to take something that's kind of short and we're going to expand it and stretch it out and make it bigger when it comes off these. All right, so if you have something like this where you're doing log of m times n, the way they're going to have you expand this one is they're going to take whatever you've got that's multiplication, and when we expand it off, we're going to take the multiplication and we're going to turn it into an addition problem. So we're going to do log of the first number plus the log of the second number that's multiplied together. Okay. And as far as these go, the bases are going to be the same. So if this had been, and we'll give you one with some actual numbers in it here. So if you were doing the log of 3x base 2, because that's something that we're more, this is like just the basic property that they do here without it. This is something you more than likely see. We're going to do the log of 3 base 2 plus the log of x base 2. Okay. And again, we'll come back and do some more of these, but that's just the basics that we're looking at. Second thing we'll do is the quotient product. Or sorry, quotient property. Again, we're going to ask you to expand. All right, so for quotient property, we're going to take the log of m divided by n. Again, if we go base b, whatever it's going to be for this part of it. And if multiplication was paired with addition, division is going to be paired with subtraction. So we're going to do the log of m base b minus the log of n base b. Okay, so if you had to do the log of 9 over 17 base 5, if they ask you to expand it, that would be the log of 9 base 5 minus the log of 17 base 5. Okay, and the third property that we're going to do is the power property. Okay, and it's not he who has the power gets to make all the properties. That's a little different power rule there. And it's expansion, but it doesn't really expand it. It doesn't really make it longer. So it looks something like this. If you have log of, and again, it doesn't really matter what the base is, but if you've got something to the n power or whatever it's going to be, it's not quite as long as the other ones. You're going to take whatever the power you have here, you're going to move it out front, so you're going to do the log times, or n times the log of m base b. Okay, so if you had to do the log of x squared base 3, all you're going to do is you're going to take the 2 that you have here and move it in front of the log expression and just leave it so it's base 3. Okay, and that's it. That's the only 3 properties that you have to worry about as we're going through these. So what we'll do is we're going to look at some of these, and we're going to look at a couple of these where we give you some problems, have you work through them, mixing in all these. And then we're going to have it, after that, we're going to go back and kind of bring in some of the simplifying that we are doing yesterday. So we're going to kind of mix in a little bit of new and a little bit of old from the last part of what we were doing yesterday. Okay, so here we go. So this is where they're going to tell you to use the log properties to expand. All right, so maybe something like this, where you've got log of 250 over x squared base 3. All right, so you've got 2 things you got to look at. First off, you've got 250 divided by x on this part, but you've also got to the second power. Since it's basically the whole thing to the second power, the first thing we're going to do is we're going to move that 2 that's up here, and let's go ahead and move that 2 so it's 2 times the log of 250 over x base 3. Okay. And again, you could kind of put, if you want to put a big bracket around this, you could. For now, we'll just kind of leave it here. But if you want to kind of go back and put a bracket around it, it's basically like that. It's still 2 times that entire thing that's here, because it's still this whole thing to the second power. So it's 2 times this whole thing. Okay. With the log of 250 over x, we're going to turn that into a division problem. So it's log of 250 base 3, and we're going to do minus the log of x base 3. Again, because the whole thing was to the second power, basically we get to go back and put a bracket, or you can put parentheses around that whole thing to make it like that. Okay, and they may let you leave the answer like this. Sometimes they'll kind of go back and forth. If they don't like this answer, you could go ahead and do an or for this part. They may make you do distributive property, so you would do 2 times the log of 250 base 3 minus 2 times the log of x base 3. So either one of those 2 should be okay. I would try this one first, and if they don't like that answer, then you can go ahead and just do distributive property with the 2. So it's 2 times the log and then 2 times the log, and leave it like that. So that's one you just have to kind of check it and see which way they let you do it there. All right, so for this one, let's go with log of 5x squared with the base 31. Okay, big difference on this one is it's not 5x, the whole thing squared. It's only x squared. So really this is 5 times x squared. So to break this one up, we would do the log of 5 and the log of x squared. And because that's a times in the middle, we're going to do a plus there. So it's the log of 5 base 31, the log of x squared base 31. Okay, this one's good because we're nothing else you can do to simplify that one. This one, though, you've got the power that's here. So we can take that 2 that's in the power, move it out in front of the log expression. So it would be 2 times the log of x base 31 and then the log of 5 base 31. Okay, and the last one we'll look at before we change it up just a little bit. We've got log of x to the third over 5. If they don't give you a base, don't worry about a base. So for this one, it's the division part. So it's just, now this one's just x to the third divided by 5. So we'll make it log of x to the third minus log 5. And then because of the 3, we'll take the 3, move it in front, make it 3 times log of x, and then minus log 5. Okay, so if they ask you just to expand it, that's all they're going to ask you to do. Now, one thing they're going to do on this one to kind of tack on a little bit is they're going to ask you on the next part of it, on some of these, is they're going to ask you to expand, and then they'll tack on just a little bit that they're going to ask you to expand and simplify if possible. Okay, so we'll get the expansion part of it first, and then we'll come back and look at the second part of it. So, okay, so this part will be just like what we're doing up here where we're going to expand it. We'll come back and simplify at the end. If we've got log of 9x base 3, well, that's 9 times x. So that's the log of 9 plus the log of x. And again, they're both base 3. Okay, so the expanding part, it's not anything different. It's still the same thing we would do in all the other stuff. Now, here's where the simplifying comes in. The simplifying part says, all right, if you get part of your answer and it's all numbers, it's all coefficients, it's all constants, then this is where you want to look to see if you can simplify this number. And the way we're going to do this one is that if you have something like this where, that again, you don't have a variable in here that it's all numbers, this is where we're going to go back to what we were doing yesterday, that we're going to take this log of 9 base 3, and we're going to figure out, okay, does this, now we're not going to use x because we got back here, so this is where we just kind of put a question mark. Could we simplify and make this thing out to be an answer of some kind of number? And what we said yesterday was that if we have this one, we're going to rewrite it in exponential. So to rewrite it in exponential is, again, we get rid of the word log. We're going to use base 3, and we're going to switch up these two numbers. So is there 3 to some power that would equal 9? Well, that'd be 3 squared, right? So if 3 squared is equal to 9, that question mark that we're looking for equals 2. So what we're saying is that this whole thing, this log of 9 base 3, that really, if we plug it in and figure this thing out, that's actually 2. So we can kind of take this part out and just make that 2. And then plus the log of x base 3. And that would be the final answer that we're looking for there. Okay, so you're only looking to simplify the part that doesn't have a variable. If this part doesn't have a variable, then you look to see if you can simplify it. And in most cases, for one like that, if it's, again, if there's no variable with it, there's probably something in this one that you can do to simplify and break it down. They might possibly get a little bit sneaky. But probably most cases, if you get it to where there's no variables, you can probably simplify and rewrite it in some way. Now, in a second, I'm going to show you another way you can do this without, it's an easier way to use your calculator to get there, but let me show you one more of these, and then we'll come back and show you what that would be. All right, so let's do the log of x to the 5th over 64, and let's make it base 2. Okay, so we'll do the expanding first, just like we've been doing with all the other problems. We're going to do the log of x to the 5th, because it's divided by, that's going to be minus the log of 64, and they're both base 2. All right, and with this one, we've got the log of x to the fifth. This is your power property, so you can take the 5 that's here, move it out front, so you can make it 5 times the log of x, base 2. And then this part is where we're going to try to figure out, okay, if we've got the log of 64, base 2, the question mark is, does that equal some number that we could go back and rewrite this thing as? Okay. And again, if it's written here, we can go back and rewrite it in exponential. So if we do that, again, we'll get rid of the word log. So it's 2 to what power equals 64? Okay. Again, we're going to go back and rewrite it so we can figure this thing out. All right. Now, if you go through your powers of 2, and we'll do that on the side over here. 2 to the first we know is 2. 2 squared is 4. 2 to the third is 8. 2 to the fourth would be 16. 2 to the fifth would be 32. 2 to the sixth would be 64. So since 2 to the sixth would be the same thing as 64, then that means our question mark then would equal 6. So again, we can take this whole expression out that's here, this log of 64 base 2. We can replace that whole thing with just a 6. So then our final answer would be log of x base 2 and then minus 6. Okay, so here's what we're going to do. This is something that you can do because some people are like, well, I don't recognize that. It's hard for me to think about it because we just started doing it yesterday. Here's something that you can do where we're going to use your calculators. Okay, and this is a biggie because this is one where you get to use your calculator and it makes the work a lot easier when you're trying to think through these. So now here's what they technically want you to do. They still, on the problems that we're doing here, because there'll be some problems that they will tell you not to use your calculator, which means they want you to do this. But you can always use your calculator to check and make sure you got the right answer. So when you see those problems where it says don't use your calculator, they want you to think about it this way. But realize you can still use your calculator to check to see if you've got the right answer. So there's nothing wrong with using your calculator to check. I mean, that's what it's there for. It's there to help things out. So here's what you're going to do. Calculators use base 10 for log. And again, if we're going back to what do I do in the calculator? If we go back to our calculators, we're talking about yesterday using the log button that's right here. When the calculator does this, when it puts in the word log, it automatically puts a base 10 down here. So calculators use base 10 for log. Now, and there's also a button, and we'll talk about this more the next couple of days. Right below this, there's an LN button that also goes with log. It's kind of it's like a cousin or it's almost like a brother or sister to log for this thing, really. And we're going to talk about that more in the next couple of days. And they use base E, and people are like, what's E? We'll talk about that again in the next couple of days for LN. So, and that's automatically programming the calculators. That's two things that calculators have that doesn't change. Every calculator is based the same way. Okay, so to use a calculator, you must rewrite an expression or whatever we want to call it here. In base 10. And here's where we get to use the formula. So if you have the log of some number where the base is not 10, doesn't matter what it is we're going to do for this thing. So it's the log of some number, some base, doesn't matter what it's, and again, something that's not 10. What we're going to do is we're going to rewrite this where it's the log of n base 10 divided by the log of b base 10. Okay, now, and realize that, again, what we talked about yesterday, that if you don't have a base shown, so it could just be log of n divided by log of b, that if you don't put a base there, it's automatically assuming base 10. So that's kind of something you can look at it too. Sometimes they'll show it this way, sometimes they show it that way. Just realize you can kind of interchange those two and be okay with what it's looking at. Okay, and then once you've got it here, then you get to use your calculator. And we'll show you how to do that. All right, so what we'll do is we'll actually go back to the problem we had before this one, where we were doing this problem where we had the log of 64 base 2. Just to show you how this would work. So we had log of 64 base 2. Again, we took it and rewrote it in exponential and got the answer from this thing. We're going to show you how you could have done the same thing with your calculator to get what you were looking for. All right, so it looks something like this. It's going to be the log of the top number, base 10, divided by the log of the bottom number, also base 10. Okay, and on your calculator, you can do this a couple different ways. If you want to do log of 64, now if you're going to do it all in one big step, you've got to close this parentheses off. Just like when we were doing, I'm trying to remember which one it was we were doing. We were doing something a while back where it was the same way. We had some kind of division problem, and you had to close this thing off because if you didn't, it was going to mess up the math that you were doing. This one's the same way. You have to do log of 64 and then do divided by the log of 2. And if you do that, then you get 6. All right, now, if you did it one step at a time, you could do log. If you don't want to close it off, you could do log of 64, hit equals, and get that number, and then do divided by the log of 2. And then it would give you the number 6 there. So either way you go, it's fine. Just realize that if you try to do it all in one step, you've got to close this number off in parentheses when you go through there. Okay, and it would have worked the same way with the problem before that one, the very first one did, where we had log of 9 base 3. We could have done the same thing with that one. If you were working on that problem and you were like, well, I'm not sure, I got an answer, but I'm going to check it just to make sure it's the correct answer, well, then you could go back and check it to do the log of 9 divided by the log of 3. And again, if you don't put the base on here, that's fine, because if you don't put a base, then it's automatically understood that that's base 10. So we're going to do log of 9. And again, if we're going to do it all in one step, close off that first number, divided by log of 3. And we do get an answer of 2. All right, now, not every number that you check on these is going to come out to be a whole number. Some of these are going to have some decimals along the way. And they should tell you to round it off to 1 decimal place or 2 decimal places or 3 decimal places or whatever it is that they tell you to do. So if you get something like this one, let's say you have the log of 27 base 81. That's the log of 27 divided by the log of 81. So if we do log of 27 divided by the log of 81, divide those two numbers, that comes out to be 0.75. Okay, now, and if the part that we're doing back here where it tells you to, expand and simplify for this thing, or rewrite it and simplify. If it comes out that that's a decimal number, you won't have to rewrite that one. You would just leave that answer like this. If it doesn't come out to be a whole number, then you don't have to worry about it, because that's one where they would probably tell you not to use a calculator. That you would, just use the log properties to do that one. So if you get a decimal number, then you would not have to worry about putting that thing in there. So it could be that you do like log of 36 base 5. All right, again, it's just log of the top number divided by log of the bottom number. And checking that, we get 2 points. Now, this is one you're going to have to round off. It's 2.227 if we go 3 decimal places. All right, again, that's one where they would tell you to round it to 1 or 2 or 3 decimal places, or whatever the case may be. All right, if you've got a phone or a calculator, you want to check one real quick just to make sure it works. Let's do log of 7 base 9. Now, I would say use a calculator, because if you use your phone, depending on which phones you have, I'm going to show you what mine would be, because I got an iPhone, and it's about 50-50. Some of y'all are folks are iPhones, other half are Samsungs or Googles, whatever we got there. The log button on this one is right here where you got the log of, it shows the 10 for the base to let you know it's base 10. But if you're going to use your smartphone calculator, at least the ones on the iPhone, if you've got to do the log of 7, I'm going to go back to this one up here, because we'll let you do that one on your own. If you're doing a log of 36 base 5, if you do the log of 36, you actually have to put the number first. You have to do 36 and then hit the log button. And then do divided by 5 and then log, and then hit equals. And then now you get the answer that's there. So if you're using at least an iPhone calculator, it's going to do it backwards. You've got to put in the number and then hit the log button, because it's the way it's programmed in. It's done a little bit different. This was a free app a while back. It was Math Studio. I don't see the log button on this one. No. There's an LN button, but there's not a log button. But that one would probably work the same way. Hang on, it's clear. No. No, you can scroll through and find these. But yeah, and again, this one's free. If you're not using it a lot, I wouldn't worry about it. If I wasn't using, you can do the log of 36 and then divided by, log 5. So if you've got a good calculator that you could punch in, you could do that. And it gives me a syntax error because I put something in there wrong. Oh, I got double parentheses. That's why. But anyway, so there's different options you can do. All right, if you were checking this one, anybody want to check, see what you get for that one? And even this one, went back and looked here. I tried to punch it in. It didn't even. I put log of 36 divided by log 5 with the Math Studio, and it took it, separated it in 2 parts like that one. So it didn't really help out a lot. But if you're doing it correctly, should have gotten like 0.886 if you're doing log of 7 base 9. Okay, so there's a change of base that's a little bit easier way to kind of go through and do some parts of it. It's a way to check to make sure if you did rewrite it and try to solve it and simplify it, that you've got the right answer when you're going through those. All right, last thing we have to do is they're going to tell you to use the properties to condense. Condense just means you rewrite it using the word log just one time. So before we took it where you had log written once and you had to break it out and use it 2 or 3 or 4 times, whatever it may be. The case is where we're going opposite. This is where you got log written 2 or 3 or 4 times, and you got to bring it back together where you're just going to use log one time. So it may start off with something like this, where we've got log of 5x plus log of 4x, or log of 3x, and they're both base 4. Okay, so this is where you're kind of doing everything backwards. This has got a plus sign between the two logs, so that means that when we put these two back together, it's going to be 5x times 3x. Still stays base 4. Somebody may be asking, will these ever be different bases? No, they should all be the same bases. If they're different bases, then you can't put these back together, so I don't think there will ever be a spot where those will be different bases. All right, and then once you're there, you're just going to multiply together what you have. 5 times 3 is 15. X times x is x squared. All right, for the next one, let's go with 6 times the log of x base 2 minus 5 times the log of y base 2. Okay, and this one's kind of like order of operations, kind of along those same lines. If you have parentheses, you would do parentheses first. We don't have any parentheses in this case, so we don't do that one. Next thing is you would go back and do your exponents. You got your parentheses, you got your exponents. So really, this 6 times this one, if we rewrite it, that would move the 6 up here. So that's going to make that log of x to the 6th power minus log of y to the 5th power. Because those are kind of your exponents where you're taking this number and moving up to making an exponent. And the subtraction sign in the middle, well, that's where that means that's a division problem. So that's the log of x to the 6th divided by y to the 5th, and it's base 2. Okay, and they will also ask you on some of these to simplify it if you're able to. So it's kind of like when we're doing expanding and you get finished with it and you don't have any variables left over, you can simplify it down. This one's the same thing, that if you're working through a problem and you get to the end and there's no variables, well, then you see if you can simplify that number just a little bit. So start with log of 32 base 4 minus log of 2 base 4. All right, you got the minus in the middle. So that is log of base 4, and that's going to be 32 divided by 2. All right, and for that one, you've got 32 divided by 2. Well, that is 16. And there's one where, now again, technically they would tell you not to use your calculator, but that's one where, you can go back and rewrite it in the exponential form and check it and see. But, to me, that's one where you kind of know if you need to work on it, because then you can take this number, you can take log of 16 and divide it by log of 4, and you get 2. So then the answer is going to be 2. And some people start going, wait a minute. They're like, so you mean we could have done that yesterday when it told us to go back and simplify and solve these? So, yeah, we could go back to some of the problems we had yesterday. Where was some of them? Oh, here we go. Like like this one back here, example 3, we were doing yesterday where it told us to solve. And this one we had log of 3 base 9. We could have punched, if it gives you this part, you can just punch that in the calculator and see what answer you're going to get. The only question on that one is if you do log of 3 base 9, then depending on the calculator, like this particular calculator, it's not going to give it to you in fraction form. It's going to give you a decimal, but then you have to take the decimal and then change it back in to get the answer that would be a half. So, so depending on what we're going to do for this thing, it may give you the right answer, but it just may not give it to you in the correct form. That's the only thing you have to kind of be a little bit careful of. All right, a couple more of these and then we'll wrap it up. So let's go log of x base 6. Sorry, log of 6 base x, log of 9 base x. Okay, and again, no parentheses. So the next thing is we're looking for power. So we've got this number that's in front with 2 times log, that if you rewrite it, that's really 6 squared. Go ahead and do 6 squared, make it 36. And then because it's log of 36 plus log of 9, that means we'll do log of 36 times 9. And if you check 36 times 9, 36 times 10 would be 360. So it's got to be a little bit smaller than 360. If we check that, that's going to be the log of 324. All right, and again, there's nothing you can do to simplify this one because you've got the variable here, so you just have to leave it like that. All right, last one today. We'll do log of 729 base 3 minus the log of 27 base 3. All right, because of the minus in the middle, put it together. So that's 729 divided by 27. And if you don't know what 729 divided by 27 is, don't feel bad because I don't either. 729 divided by 27, that is 27. So that's the log of 27 base 3. And now that you've got it down to just some number, this is where you get to, again, to go back and use your calculator. So that's going to be the log of 27. Hang on. Close it off, divided by the log of 3. And if we check the log of 27 divided by log of 3, that comes out to be just a plain old 3. All right, now, again, if you got here, if this was like log of 28 base 3, and you got some weird decimal number, so if we did log of 28 divided by log of 3, if you got some decimal number like this, you wouldn't worry about simplifying that one. You would just leave it as log of 28 base 3. If you get a whole number, that's when you want to go through and simplify and break it down to a point.